Here we go with lesson one. Welcome to the vectors portion of the calculus and vectors course. This first unit really just focuses on getting you used to the idea of vectors and being able to use them. Today we're just going to get your feet wet with some new vocabulary that you'll be using. Our learning goal will pretty much be the same throughout the whole first part of this unit. So we're seeking to understand vectors in 2 space and 3 space, in other words, in 2 dimensions and 3 dimensions, using algebraic and geometric representations, and to recognize how they can be applied. So in order to meet that goal, we definitely need to know how to talk about vectors. So let's start with what a scalar is. This is something you're very used to. You've been using scalars your whole life. A scalar is any value without direction. So for instance, knowing the speed of a plane, right? Speed itself is a scalar all the time. Distance is a scalar. Acceleration often is a scalar. There are lots of examples you could use here. Mass. Then we get into vectors. This is what we're introducing today. So a vector is a value that has both magnitude and direction. So this would be something like velocity or displacement. Those are often very physics examples. We talk about bearings all the time when you're thinking about the direction that something is traveling. Generally, that's going to have a speed with a direction. That's what makes something a velocity. So here we have a line. At least at the moment, it's just a line. And we're going to turn it into the example that we have written there. So in order to turn that line into a vector, it has to have a particular direction, which means we're going to use an arrowhead to show the direction that that is. And because we're calling this AB, we're also going to label it. So A is where the tail of the vector starts, and B is where the head of the vector ends. And you can notice that we can also label this in a different way. So we can also use a letter to just label the actual arrow. And generally that'll be done with a lowercase. So uppercase to represent ends, just like when you drew geometric shapes in previous grades, right? We labeled the vertices with capital letters. And also to finish these labels, we actually need to have a vector symbol over top of them. So AB will have an arrow on it. You can draw it with a full arrowhead at the tip there, but you can do it in one pencil stroke by doing what you see there. And the same thing would go for the V. So we would have to put the little arrowhead over the V. So it would have the magnitude of the absolute value of AB. Or if you're going to use the V symbol, then it's the absolute value of V. So that would correspond to the length, and you'd have a specific scale on your picture to make that actually have a specific value. Now, vectors can be opposites of each other. So if you have 2 vectors with the same magnitude but opposite directions, in other words, you'll end up having AB being negative BA. Sorry, that's the highlighter instead of the pencil. Right, so AB is equal to negative BA. So if this here is AB, so we have it going that way, then when you draw it this way, you have opposites. So they're equal in magnitude, but opposite in direction. We also need to be able to represent equal vectors, because they can have different labels, but still be equal. So 2 vectors, A, B, and CD are equivalent if and only if these 2 cases are true. So A, B, and CD have to be parallel to each other, and the direction from A to B is the same as from C to D. So we can show that by making sure these 2 vectors go the same direction. And this one would be labeled AB. This one would be CD. And you also have to have that the magnitude of AB and the magnitude of CD are equal. So that's the lengths, right, corresponding to the two lengths. So these two vectors are equal vectors. They have different labels, but they are identical in direction and length. And just a quick reminder, you've probably seen this briefly before. This if and only if statement here means that this definition works both ways. So this thing is true if these are true, but also these are true if this is true. So it goes back and forth. All right, so what you've actually been looking at so far are geometric vectors. So these are vectors without reference to coordinate axes. So these are what we've been working with so far today. And those of you who have taken physics, you're used to working with geometric vectors all the time. We will be moving towards algebraic vectors. You'll start to see a little bit of that in today's work. But as this progresses in our unit, you'll start to see this even more. And I apologize if you're getting strange noises through this microphone. My cat has decided to come up and join me and keep slapping her tail on the screen. So here's a few examples of things that you might actually be asked to do using vectors through the next couple of days. So we're going to do things like identify whether something is vector or scalar. So I could ask you to tell me if, let's say, a boat was traveling at 6 knots and traveling in a northerly direction. You'd have to tell me if that's vector or scalar. That one would be vector because I'm giving you a quantity and a direction. You'd also be asked to identify equivalent, opposite, and perpendicular vectors. So, for instance, you might be given a diagram, and you'll have to. So great skills in this program at the moment. I managed to leave my work iPad behind and don't have my iPad, my Apple Pencil either. So you're putting up with my less than stellar materials here. Okay, so we have a diagram and we could use this to identify equivalent, opposite, or perpendicular vectors. So for instance, we can see here by looking at BC and AD would be equivalent vectors. We can also see that AB and CD are opposite vectors. You can also pick, of course, a pair that would be perpendicular. So that's what I mean by that. You'll also have to draw equivalent vectors, opposite vectors, or vectors given specific criteria. So for instance, you could be told to, given a vector, draw a vector that is the same direction but 3 times the length. And so you'd have to finish that drawing. Using a scale diagram, draw vectors to represent a given situation. So like you could be told that a plane is traveling at 300 kilometers per hour northwest. So you'd have to use a specific scale to represent a vector so that you could represent that exact situation. You may have to interpret given vectors in a known context. So this would be kind of the reverse of 4, where you're already given the vector and you're told that it's a plane flying and you have to then assign it a value and a direction. And you could also have to determine magnitudes of vectors given a diagram, context, or 2 coordinate pairs. So for the diagram, for instance, if we use the diagram that we had above, I could ask you for the magnitude of the vector AC. So you can see that the vector there doesn't actually exist yet, but we can definitely draw it. And if we know the magnitudes of AB and BC, we can definitely find a magnitude of AC. You could also be given 2 coordinate pairs. So for instance, you could be told that a vector, say, starts at 2, 2, and let's say it ends at 5, 4, and then you would have to figure out what the magnitude of that vector is. And that concludes this portion of our lesson. Thank you for listening.